Welcome to MOVIMOT and Field Distributors Basic and Intermediate Training. This is session number 3. We've learned a lot about MOVIMOT, we've covered a lot of background, and now we're finally ready to do a startup. Startup on MOVIMOT is quite different from many other VFDs. The big difference is you don't even need a computer or a keypad or any kind of user interface. You can do what is called an easy startup using just a screwdriver, and that is basically it. So we're going to learn to do the easy startup because that's what most people do with their MOVIMOTs, although there are certainly more advanced modes available as well. This is part 1. It's actually going to take 2 videos to go through this, not because it's difficult, but because there are a lot of possibilities that we have to explain to make this clear. In this session, we're going to cover about 3/4 of an easy mode startup, so let's dive in and go. Before we do this, I need to give you the obligatory safety reminder. I've told you in previous sessions, and I'm going to tell you again, always disconnect power and wait at least 1 minute before removing the control head. Remember, this is to allow the capacitors time to discharge. If you take the control head off immediately after powering off, you could get shocked. All right, the very first step of an easy mode startup begins on the top of the control head. You need to remove the plug covering the F1 dial. Remember, this sets one of the 2 speed set points. It's a potentiometer that you rotate between 0 and 10. So take the plug off to expose the dial and set it to one of those numbers. Now you're probably wondering, well, what's that do? How do I pick a speed? Well, to set this dial correctly and get the speed you want, you need to understand something very basic. This dial sets the VFD's output frequency. Now, if you remember, in a previous session, I explained that the motor's speed depends on 2 things. It depends on the number of poles in the motor and the frequency that the VFD is outputting. By setting the frequency, we set the speed. And this little graph here shows you the relationship between the numbers on the dial and frequency. You notice, for example, if you turn the dial to 5, which is near the middle, you'll get a frequency of 50 hertz. However, as I've said several times, and I'll just say again, the actual speed depends on the motor, and this equation shows the relationship. For example, if I dialed a 5 into my VFD, that would set the frequency to 50 hertz. If I took this equation and I took 120 times 50 hertz and then divided by, say, a 4-pole motor, I would get a speed of 1500 RPM. That is the relationship between the dial, frequency, and the actual motor speed. So you need to know how many poles you have on your motor. Motor poles vary, but 4-pole motors are probably the most common. The examples that I'll be doing will all be based on 4-pole motors because that's what my demo unit has. What this dial does is it establishes the speed set point, which is called the F1 set point, if you're operating in binary control mode. That's the mode we're going to work in here, but easy mode startup also does apply to RS-485 mode. But in binary mode, this sets the speed set point. So when you run the motor, you have 2 set points available in binary mode. This is one of them. It's usually the higher speed. Okay, but if you're an RS-485, it behaves a little differently. It establishes the maximum speed. In binary mode, you just have 2 speeds you can pick from. But in RS-485 mode, you have totally controllable speeds ranging between a minimum and maximum value. And you have complete control within that range. You can pick any speed between those 2 points. So if you're in RS-485 mode, and that includes field bus control mode through a field distributor, setting the dial here doesn't set a set point, it sets the upper limit, the highest speed you can request over the field bus or RS-485. We're working in binary mode in our example case here, so we'll just assume this is actually just our F1 set point. But be aware, the dial has those 2 relationships. All right, now let's try to make this a little clearer by doing a quick example. We have our chart here, we have our equation. Let's say that I have a 4-pole motor and I want to run it at 750 RPM when I pick the F1 set point. What do I turn the dial to? Okay, here's how you do it. First thing you need to do is take the speed equation and rearrange it to calculate frequency. So we do a little algebra and we get frequency over on the left side, and we have this new equation. You take your desired speed, you multiply it by the number of poles in the motor, and divide by 120. We have all the information we need to calculate frequency now. We take 750 RPM times 4 poles and divide by 120, and that gives us a frequency of 25 Hertz. So we need to turn the dial to a position that gives us 25 Hertz. We use the little graph for this. We go to the 25 on the y-axis, the vertical axis, and we go across until we hit the line. There's where we hit the line from 25 Hertz. We then go straight down till we touch the x-axis, the horizontal axis, and that is our number that we dial into the VFD. We notice we're between 2 and 3. Now the F1 dial is a potentiometer, and you can set it between numbers, so that's easy. We set our F1 dial halfway between 2 and 3, and that should give us 750 RPM on a 4-pole motor. That wasn't too hard. All right, so that's step 1. Now step 2, we flip our control head over, and we have to set the F2 dial. That's the green dial. It has numbers between 0 and 10 as well. However, they click. You can't set in between, so you're going to have to pick a number. This may not give you exactly what you want. You'll have to just pick the closest value. The F2 dial sets another speed. It also, however, sets frequency. There's a little table in the MOVIMOT manual that shows you the frequencies you get from the F2 dial. Again, remember, the actual speed depends on the motor, depends how many poles you have. We're going to continue with our 4-pole motor. Now, if you're in binary control mode, this row determines the speed it operates at, as I've said, so you'll have to read this row. If you're in RS-485 mode, the other row applies. Now, in binary mode, this gives you your second speed. Remember, you just have 2 speeds in binary mode. This is the other one. If you're in RS-485 mode, this sets the lowest speed you can run. So this sets the lower limit. You'll need to pick the right row for what you're trying to do. Let's do an example here. Again, we're going to stick with binary mode. We have our equation. Notice this is the rearranged equation to solve for frequency. Let's say we want our F2 speed to be a slower speed, 150 RPM. Of course, our motor still has 4 poles. So we plug 150 in. We multiply that by 4, and we divide by 120, and that gives us a frequency of 5 Hertz. So we need to go to the setpoint F2 row in this chart here and find 5 Hertz. It's right there. We go up, and that tells us what position the dial has to be set to, and that one actually can be set exactly, so we set our dial to 0. And if we do that, we're all set to go, operating at 150 RPM. So in binary mode, we'll have 2 speeds, 750 RPM and 150 RPM, and that's it. Of course, we always have stop, which is 0. If we were in RS-485 mode for some reason, or field bus mode, we would pick a different position on the dial. We'd have to use the bottom row of the chart, and we would read up and we'd get a position of 1. So remember, use the correct row for what you're doing. We're using binary mode, so we'll use 0. All right, now we have to move on to setting something else known as the ramp. And here I need to define some terms to make sure we're all on the same page. First of all, I'm going to give you the term acceleration. Now, in everyday life, like when we're driving our cars, we think of acceleration as increasing your speed. But if you've ever taken a physics class or any kind of engineering class, you know that engineers and physicists don't define acceleration that way. Acceleration to them means any change in speed and or direction. In other words, speeding up or slowing down are both accelerations, even though in everyday life we call slowing down deceleration. Well, it turns out SEW Eurodrive with MOVIMOT and many of its older products uses acceleration in the physics sense of the word, any change in speed or direction. Bear that in mind. A second term I need to give you is ramp. I've used this a few times already, but I'm going to define it formally here. Ramp means any acceleration event, any change in speed, either speeding up or slowing down. And a third term I'm going to give you is travel diagram. This is a graph of speeds over a period of time. Many SEW Eurodrive products use travel diagrams to display the acceleration and deceleration behaviors of products. So we're going to be working with that, and we're going to see how ramps fit into that. Okay, so with those terms under control, we can move on. Let's look at a travel diagram. This is a typical travel diagram. Now remember, this graph documents speed versus time, not position. So in other words, the x-axis, the horizontal axis, represents time. The vertical axis represents speed. So if we look at this, we can see that what's happening is we have our speed being 0 in the beginning, and it continues for a period of time. It's a horizontal line. Then there's a change. That's an acceleration. You notice it goes up. You can see why we call it a ramp, because it looks like a ramp. So we have that acceleration event. Then we have a higher speed that's fixed, so the line becomes horizontal again. We then have a slowing down event, a negative acceleration, or what we would normally call a deceleration in everyday life. That's another ramp. We operate at a lower speed for a while, another horizontal line. Then we slow down some more. There's another acceleration event where we slow down. And then finally we come back to 0 again. That's a travel diagram. All right? Now, a term that we have to work with very frequently when we work with travel diagrams and when we calculate ramps is something called speed change. We need to know how the speed changes over a period of time. The way we do it is we subtract the initial speed after a change from the final speed where we wind up, and then we take the absolute value. In other words, we want to get rid of any negative signs. We don't really care about the sign. All right, so speed change is something we'll have to calculate quite a bit, and I'll show you how that works. We have, for example, here an initial speed of 0 RPM. Our drive is not running. And then we have a maximum speed here of 750 after the acceleration event. Our speed change here would be calculated as the absolute value of 750 minus 0, and that's 750 RPM. So that's our first speed change. Now we have another speed change here where we're slowing down. We go from 750 RPM to 250. So we take 250 minus 750 and we take the absolute value, and that gives us a speed change of 500 RPM. And then we have a third speed change where we go from 250 RPM to 0 RPM. So we take 0 RPM minus 250, we take the absolute value, and that gives us a speed change of 250 RPM. Those are the speed changes for our 3 ramps, the places on that diagram where our speed changes. Okay, now we don't have all the information we need yet to calculate ramps. We know how the speed changes, but we don't know how much time it took. So we need to know what's called the acceleration time. That's the time required for that change to occur. Speed changes can't happen instantaneously. Mechanical drives take time to change speeds. So we need to have times, and I'll give you some times here. Let's say that this ramp takes 1 second to occur, this one takes 0.67 seconds, and this one takes 0.33 seconds. Those are the acceleration times. Now, once we have those and we have the speed changes, we can calculate the ramps that we would program into our MOVIMOT and have it execute. Those calculations that we perform will give us what's called the ramp time. That's the time we dial into the MOVIMOT, and it will produce the desired acceleration time. So keep those terms separate. Acceleration time is what it actually takes to execute. Ramp time is simply the value you dial into the MOVIMOT or send over the field bus to tell it how quickly to speed up or slow down. Now, before we get into calculating ramp values and configuring our control head to execute them, I need to make a very important point. In easy mode with binary control, MOVIMOT has just one ramp time. In other words, the acceleration and deceleration times are identical. On the other hand, if you're in expert mode or if you're controlling the MOVIMOT by RS-485 or field bus control, more flexible ramps are possible. You can have independent acceleration and deceleration ramps. You can also configure what's called the ramp shape. We'll cover these in other sessions, but right now, since we're dealing with easy mode and binary control, we're dealing with just a single ramp time, which we dial into the control head using a physical control. You set that single ramp in easy mode, binary control mode by using this white dial here. It's called the T1 dial. It has numbers printed on it from 0 to 10. They click, so you can't set in between the numbers. You've got to pick the closest one to get the ramp that you want. And it's very important to understand that this dial sets time. And you will find this little table in the MOVIMOT manual. It gives you the time for the different positions on the dial. Now you might think, okay, that makes perfect sense. If I want to set my dial to 5, I'm going to get a 1-second ramp time for whatever speed change I do, right? And the answer is no, it doesn't work that way. This is where it gets complicated. The times on this chart represent the time for the MOVIMOT to do a 50 Hertz frequency change. In other words, if you go from 0 Hertz to 50 Hertz, it will take 1 second if you set the dial to 5. And if you go from 50 Hertz back to 0, it'll take you 1 second. Or if you go from 50 Hertz to 100 Hertz, it will take 1 second. Now, the problem is that a 50 Hertz change does not give the same speed change with different motors. Remember, you have to know the poles of a motor to know what kind of speed change a given frequency change produces. That means the actual acceleration time that you have depends on the motor and how many poles it has, because the number of poles affect what the actual speed change is. Now, in most cases, when you're setting up an application and you're setting up ramps, you're interested in speed change. So how do we relate this table, which is basically tied to just a 50 Hertz change, to a particular motor with a particular number of poles and a desired speed change? Well, the answer is you have to do some math. And the math will give you a number that you can plug into this table and then decide what position to set the dial to. Let me show you the equations, and these actually aren't in the MOVIMOT manual. I created them for this class. I've created 2 of them. You can use whichever one you like. If you're interested in a speed change, you can use the first equation. If for some reason you're thinking in terms of frequency change, you can use the second equation. You'll probably use the first equation most of the time, and I'm going to do 2 examples to illustrate how this works. So if this is a little confusing to you, don't worry, just hang in there, all will become clear. I do want to make one point first before we do the example though. When you dial in the ramp on the T1 dial, this sets the ramp for most control modes, but not all. Even in field bus mode, it's possible to use the value dialed into this dial, although you don't necessarily have to. Again, I'll explain that more in later sessions. Right now though, let's just worry about calculating ramp values. Let's do an example here where we talk about a desired speed change for a given motor. And I'm going to use those values we just used a few minutes ago when we were setting up the F1 and the F2 dials. Let's assume we're going to do that 750 RPM speed change. In other words, we're going to use the F1 dial speed. We're going to maybe take the motor from a full stop up to the F1 speed, that's 750 RPM. Or we're going to come from 750 RPM down to 0. All right, so we're going to use that value. That's our speed change. I'm also going to just tell you the motor has 4 poles. Of course, we do have to pick an acceleration time. We have to say how much time we want it to take for this 750 RPM change. Let's just say I want it to take 1 second. Okay, so I want to go from 0 to 750 or 750 to 0 in 1 second. Now, I might be tempted just to go up to my table, find 1 second, and pick the dial setting, which in this case is 5. But that wouldn't work because that's a 50 Hertz change, and this is not a 50 Hertz change. It's something different. We need to use our equation here. Here's what we do. We take our acceleration time, which is 1 second, and then we multiply it by 6,000 divided by the speed change times the number of motor poles. We take 1 second times 6,000 divided by 750 RPM times 4. And the answer that comes out of that is 2 seconds. We then take 2 seconds and we go up to the table and we find the closest value to that, which in this case we're lucky. There actually is a 2 there. So we take 2 seconds and then we take the number above it, and that's what we dial in, which is 6 in this case. That is how you correlate a speed change for a motor with a given number of poles and a desired acceleration time, and you can turn it into a dial setting. I hope that wasn't too confusing. If it is, watch this again. I think you'll understand it. All right, so if we're dealing with speed change, this example illustrates it very well. Now let's do another example where we look at frequency change instead. Let's say we actually are thinking in terms of a frequency change and we want to calculate a ramp time. Let's do it this way. We're going to change equations. We're going to use this other equation here. Let's say we have a frequency change of 25 Hertz. We go from 0 to 25 or 25 to 0. We also have a 4-pole motor, which here we really don't care about because you don't actually have to plug that into the equation here. We have to figure out what ramp do we dial in to get a given acceleration. Again, I'm going to say let's have an acceleration time of 1 second. So we take 1 second and then we multiply it by 50 divided by 25. And the answer is 2 seconds. Unsurprisingly, this is the frequency change for that F1 speed change. So this is actually an identical answer to what we got for the previous example. We go up to our chart here, we find 2 seconds, and we get the number, which is 6. And that is how you set things up. All right, well, I hope that made sense. This is how you set the ramp dial. So the ramp dial is probably the most complicated of the three to set. Once you've figured it out, though, it's really not too terrible. Okay, hope that helped. All right, so it's time for a hands-on. We're now going to set up a MOVIMOT, configure it to operate for a set of conditions. Let's go ahead and do that. What we would do first is we would turn off our MOVIMOT, disconnect its power, render it electrically safe, then sit back and wait for 1 minute, so take a sip of coffee or something like that. Wait for a minute, take those 4 bolts off the top, pop off the top, and get ready to set it up. So here are the instructions, and if you have an actual demo unit, feel free to go ahead, pause the video, and do this. I will show it here. We're going to first of all control our MOVIMOT in binary control mode. We're going to set it up in easy mode, obviously, and we need to set those 3 dials. So I want you to calculate and set the F1 dial to give you 1200 RPM. I want you to calculate and set the F2 dial to give you 300 RPM. And then I want you to calculate and set the T1 time dial for a 3-second ramp when you do an F1 speed change. In other words, a change from 0 to 1200 RPM or 1200 to 0. Now, of course, you'll need to know how many poles your motor has in order to set these correctly. My demo unit has a 4-pole motor, so I'm going to be basing it on that. If you wish to do the hands-on, go ahead and pause the video, do it, and then come back. You can watch me demonstrate it. And if you don't have a demo unit, just wait a few seconds and you can watch me demonstrate how to do it on my demo unit. All right, so time for my demonstration here. I have shut off my demo unit, electrically made it safe, waited a minute, I've unbolted the head and taken it off. So I need to calculate my F1 speed first to set the F1 dial. That was 1200 RPM. I have a 4-pole motor. So I use my frequency equation here and I plug in 1200 RPM times 4 poles divided by 120, and that gives me 40 hertz. I need to go onto my little chart here and I need to estimate where 40 hertz is, somewhere between 25 and 50. It's about here. I read across to the line and then I go down and I discover I am right behind 4. So that means I set my F1 dial just a hair below 4, and that should give me 1200 RPM with my particular motor. Okay, so that's my F1 dial. I now move on to my F2 position. I need 300 RPM. I take my frequency equation and I plug in 300 RPM and 4 poles. I take 300 times 4 divided by 120, and that is 10 hertz. I then go to my set point F2 row, because remember, we're in binary mode, and I find 10 hertz, and I read up, and that says set your F2 dial to a 2, and that will give you 300 RPM, because that is the right frequency with a 4-pole motor to turn it at 300 RPM. All right, last thing to do is calculate the T1 time to get the acceleration. Now, I said for an F1 speed change, that's a change where the speed changes by 1200 RPM. And I said I wanted that to take 3 seconds, so fairly slow acceleration. Again, I need to know my motor poles, and I need to have my equation here. So I'm using the speed equation that calculates the ramp. I need to plug in a speed change of 1200 RPM and 4 poles into this, so I use the equation like this. I take 3 seconds, that's my acceleration time, multiply it by 6,000 divided by 1200 RPM times 4 poles. I crank that through and I get 3.75 seconds. That is what I need to dial into the MOVIMOT to get a 3-second ramp with a 1200 RPM speed change. Now, this is kind of a problem because there is no 3.75 time on my chart. I can either pick a 3-second or a 5-second time. So that means I have to pick one of these two positions. I either have to have a slightly too slow or slightly too fast ramp. This is my call. I would set it to either 7 or 8. I'm going to just pick 7 because 7 is close. Okay, those 3 calculations are now over, so now what I need to do is set my dials, and here's how I would set them. I would set my F1 dial, the potentiometer, to just a hair below 4, and I've done that here, you can see. Then I need to go to the underside of the control head, and I set the green dial to a 2, and I set the white dial to either a 7 or 8. I've picked 7 here. And that has configured my MOVIMOT to have the 2 speeds I need with the ramp I need. And that is it for session 3. Now we are not finished with easy mode. We have to do something else. We have to set all those little dip switches underneath the control head. But that's going to take another session to explain, so we'll stop here. So maybe if you want to go ahead and take a break, that's good. Come back in session 4 and I'll show you how to complete easy mode startup. See you then.